Welcome to the Planet of Maths channel. In this episode, we will talk about drawing the graph of a linear function using a second method, a method that doesn't require creating a table at all. If someone doesn't like or isn't good at making tables, this method is just for them. Of course, it's worth knowing the method of using a table, but this method is also nice. If we need to plot a graph of a linear function like y equals 2/3 x plus 1, and here we have a fraction, using a table can be a bit tricky. We can handle it like this. Every linear function with the general form f of x equals ax plus b will definitely pass through the point 0b. We need to be able to determine the coefficients. Here, what stands next to x is the coefficient a, and it is equal to 2/3, while the constant term is coefficient b, and it is equal to 1. So since the graph of this function passes through the point 0b, so the graph must pass through the point 0b, which is 1. Thus, the graph of this function definitely passes through the point 0,1. We start from the point 0, 0. The first coordinate 0 indicates neither right nor left, and the 1 indicates we go 1 up. So, the graph of this function must definitely go through this point. And then we do it like this. We look at coefficient a, the one with x here, and if we have a fraction, the numerator tells us how many units we need to move up, while the denominator tells us if we'll move to the right or left. The denominator represents the horizontal shift, either right or left, and it depends on whether the coefficient a is positive or negative. If the coefficient a is positive, like here, 2/3, then we move to the right, and if this coefficient a were negative, we would move to the left, as indicated by this arrow, starting from the point we've already marked here. In this case, the 2 tells us to move up by 2, and the 3 tells us to move 3 to the right. And we start first with the horizontal shift, so from this point, we move 3 places to the right, 3 units to the right, and then we move 2 units up, so we end up at this point. Here we already have the second point. For the next point, we apply the same shift again, which is 3 to the right and 2 up. This is the slope of the graph of a linear function. We could also do the same in the opposite direction, but reversed. Now 2 down and 3 to the left. And here we get these steps. Here we have 3 to the right, 2 up. Here again, 3 to the right, 2 up. 3 to the right, 2 up. And the graph of this function definitely has to pass through these 4 points. So we draw this graph, and it looks like this. This way, we can graph any linear function. In example B, we have such a function, and here we see that the coefficient b is equal to 2, which means that this point 0b is otherwise the point 0, 2. So, we mark this point, 0, 2, it will be here. This is also where the graph intersects the y-axis, and our function must pass through this point. The coefficient a is equal to -1/2. This means that the 1 indicates we will move 1 unit up, and the 2 indicates we will move horizontally. But since we have a minus here, this time we will move to the left. So it will work like this. From this point, first horizontally according to the 2, we move 2 to the left, and according to the 1, we move 1 up. And this is our next point. Again, 2 to the left, 1 up, 2 to the left, 1 up, the same in the other direction but kind of reversed, like this and this. And here, we get these steps forming everywhere. 2 to the left, 1 up, 2 to the left, 1 up, 2 to the left, 1 up, and so on. We can now draw the graph of this function, and the task is complete. In example C, we have a situation where the function f of x is equal to 3x minus 3. And here we see that coefficient b is -3 and coefficient a is 3. Since b is equal to -3, our point 0b will be 0, -3. The point 0, -3 will be located in this spot. Now, there is a small issue with the coefficient a because we have the number 3, and it's not a fraction, but we can easily make a fraction out of 3. 3 whole is the same as 3 over 1. And now it goes like this. The 3 tells us to move up 3. The coefficient a is positive, so we move to the right one. So from this point, first horizontally 1 to the right. So here, and then 3 up, which means here. From there again, 1 to the right and 3 up. Just as these numbers indicate here, 1 to the right and 3 up. And these steps have formed here. 1 step, 2 steps, 3 steps. We can draw the graph of the function. This is the line. End of example C. In example D, we have the function y equals negative 2x. Here, we don't see the coefficient b, but the coefficient b is as if we added 0. The initial function and the one where I added 0 are the same function. And from this, it's clear that coefficient b is 0. So our point 0b is point 0. And instead of b, we put 0. Point 0, 0 is the origin of the coordinate system, so we start from this place. Now, coefficient a equals negative 2. Negative 2 is the same as negative 2 over 1. We simply make a fraction. Here we need a fraction, and we already have it. So the 2 tells us we'll move 2 units up, and the 1, since we have a minus here, tells us we'll shift 1 unit to the left. The 1 tells us to move 1 to the left, and the 2 tells us to move 2 up. So that's what we do from this point, 1 to the left and 2 up. Then 1 to the left and 2 up. 1 to the left and 2 up. You could do the same here. And there would also be a point somewhere here. We have these steps here, 1 to the left, 2 up, 1 to the left, 2 up, 1 to the left, 2 up, and so on. We can draw the graph of the function y equals negative 2x. End of example D. And the last example in this video, f of x equals negative 3. This is an unusual function, and we need to know that it looks like this in another way. It is the same as the function 0x minus 3. Such a 0x simply disappears. It's not written, which is why the function's formula is like this. But the full expression of this function would look like this. We see that b is equal to negative 3. So we can already establish this point. This point 0b is the point 0, negative 3, and our function must definitely pass through this point, which is here. And the coefficient a is equal to 0, and we need to express this coefficient as a fraction. So we can express it as a fraction, 0 over 1, for example, or 0 over 2, 0 over 3, 0 over 4. 0 divided by anything always equals 0. In any case, we have a fraction, and this fraction tells us that the 0 indicates we will move up 0, meaning we will not move up. And the 1 tells us that we will move 1 unit to the right. We can assume it's a positive number. So 1 to the right, 0 up. From this point, we move 1 to the right and 0 up. It's here. Again, 1 to the right and 0 up. 1 to the right and 0 up. It would be the same in the other direction, and we can draw the graph of this function. The function f of x equals negative 3. This is a constant function, so its graph is parallel to the x-axis. It is horizontal. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Maths channel.